Domination in graphs. In the earlier assignment, we had vertex cover and independent sets in graphs. Now, in this lecture, we are going to see domination in graphs. Now, recall the definition of vertex cover, that vertex cover is a subset of vertex set such that all the edges are covered by the set. That is, at least one endpoint of each edge of the graph belong to the set. Suppose we consider covering only the vertices, then the set is called a dominating set. And any vertex cover is a dominating set, but dominating set need not be a vertex cover. Now consider the graph in this example. The vertex cover could be taken as v1, v2, v5, that covers all the edges of the graph, and dominating set to be v1, v5. Now the dominating set v1, v5 it cannot be a vertex cover for the graph, but the vertex cover v1, v2, v5 is a dominating set for the graph. And also we find that vertex cover is not equal to the dominating set in this example. Now we'll go on to the definition of dominating set. In graph theory, a dominating set for a graph G equal to v, e is a subset D of V such that every vertex not in D is adjacent to at least one member of D. The domination number gamma of G is a number of vertices in a smallest dominating set for G, and the corresponding dominating set is called a minimal dominating set. We find that there is a relation between the minimum vertex cover and the minimum dominating set. Earlier we saw that the cardinality of minimum vertex set is usually denoted by beta, and hence we find that always gamma of G is less than or equal to beta of G. Even in this example that we saw in example 1, the cardinality of minimum vertex cover is 3 here, and the gamma value, gamma of this graph is equal to 2, and hence gamma of the graph is less than or equal to beta of G. Now consider this example. Some of the dominating sets are as listed below. We find that the dominating sets of a graph are not unique. In this graph, the dominating set with minimum cardinality is 2. Therefore, for this graph, gamma of G is equal to 2. Now, if you try to determine the domination number of the Peterson graph, the Peterson graph has domination number 3. Each vertex dominates itself and 3 others. So at least 3 vertices are needed. Therefore, gamma of this Peterson graph is 3. The yellow vertices shows the minimal dominating set. Now suppose if you are asked to determine the domination number of Cn and Pn for the following graphs. Cn is the cycle on n vertices and Pn is the path on n vertices. Then we have the graphs like this. We find that the colored vertices denote the dominating set, minimal dominating set. Gamma of Cn is equal to gamma of Pn equal to ceil n by 3. Cn and Pn both have a maximum degree of 2, and therefore each vertex can dominate itself and up to 2 other vertices picking every third vertex starting from the second and using the last when n is not divisible by 3 yields a dominating set of size ceil n by 3. This way you can just find the domination number for various graphs. Thank you for watching the video.